In this video, we're going to have a look at what we call in statistics causality, or whether there's a causal relationship between two variables. Now, what causality actually refers to is if there is a change in our explanatory variable, does that cause a direct change in our response variable? And to determine whether there is a causal relationship that exists between two variables, we have to look at the variables that we're comparing and use a little bit of logic to work out whether it's reasonable to conclude that a change in one variable caused a direct change in the other variable. So let's start with the three examples that I've got here. In this first example, I've got a change in speed as my explanatory variable is causing a positive change in my distance travelled variable. And we can see here that the strength of that correlation is rather strong. Now, is it logical to conclude that an increase in speed will increase the amount of distance travelled? In this case, it is quite logical to conclude that. So we would say that the relationship between these two is a causal relationship, because a change in speed does directly change the amount of distance you're going to travel. Now let's compare this to my second example, where I've got another positive linear relationship between my arm span and my height. Now, an increase in the arm span has shown that there's an increase in the height. But does increasing one's arm span directly influence how tall they actually are? Now, there's no doubting that there is definitely a correlation between these two if I was to interpret purely off of this graph here. However, increasing someone's arm span doesn't directly influence how tall they actually are. There's another variable at play here, and that variable is what we call genetics. So, whilst there is a relationship between here, the cause of that relationship was actually a third variable. So we say here that the relationship between these two, whilst it is a positive correlation between it, it's not causal. And that brings us to our third example, where as we increase the number of cat owners, the number of burglaries in that area also increases. And once again, if we would take it purely off our graph here, there is a positive linear correlation that exists between these two. But does increasing the number of cat owners in an area directly determine or change the number of burglaries in an area? Well, logically, it doesn't. So here, whilst there's a correlation that exists, it's definitely not going to be causal. The number of burglaries in the area isn't determined by the number of cat owners in the area. Doesn't mean that we should just not have any cat owners. What we would call this, if this were true, we would say that it's coincidental instead. Mind you could also argue that perhaps there are probably more cat owners in more populated areas, so a third variable might be at play of population size, but that's debatable. It's probably more logical to say that this is more of a coincidence than anything else. So a causal relationship is where a change in our explanatory variable is the direct cause of the change in our response variable. If it's not, then it's not a causal relationship.